नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्विशेट्टी, फैकल्टी ऑफ मेजरमेंट्स। मैं आप सब लोग को स्वागत कर रहा हूं सुपर 20 सीरीज पर, मेजरमेंट्स पर। ओके, इसमें क्या क्या टॉपिक्स आना है। सो वी आर गोइंग टू डिस्कस सम डिफरेंट वर्सेटाइल क्वेश्चंस of untapped areas, okay, and we also discuss some important areas to be focused, okay. Chalo, let us see now. Let us start from the first question. So see this type of question. The output of a temperature sensor is given by this, where T is in degrees Celsius and V is in volts. The sensitivity of the sensor is, don't think it is a sensor question. Why? Because in measurements we have a context called sensitivity. So how to calculate the sensitivity? Let me know it. जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए बेटा, ऑडियो वीडियो सब कुछ क्लियर या नहीं। So if you see this area, so here what is given, the temperature sensor is mentioned like this. So you can take a sensor like this. So this is our temperature sensor. So we are giving the input as T, output as V. So please remember, this is T and this is V, and the equation is given like this. So V is equal to 0.02 T plus 0.1. Sensitivity means what? Sensitivity means change in output by change in input, delta V by delta T. Okay. So now if I am taking this delta V by delta T means dV by dt. So that is the sensitivity, that is 0.0 T plus 0.1 constant, that will become 0. Constant derivation will become 0. The units are, he has given temperature in degrees Celsius, V in volts. So the answer will be 0.02 volts per degree Celsius. So the right answer is 0.02. So this is one of the characteristics of the instrument. If you see the instrument is having certain characteristics like sensitivity, accuracy, precision, resolution, like that. Okay. So this is one type of question. Now let us go for another question. What is this question? So try to answer this question. A resistance is measured 100 ohms using an instrument having accuracy of plus or minus 1%. The maximum possible true value of this resistance is dash. So try to find out these answers for this particular question. Yes, try to answer this question. A resistance is measured as 100 ohms. So the measurement value is 100 ohms. So he's asking the maximum possible true value of the resistance is dash. So accuracy is 1%. So 100 ohms plus or minus 1% of this 100 ohms. So what happens now? So this R is equal to, it is having 100 ohms plus or minus 1%. So here the measurement value is this. The measurement value is given as 100 ohms. True value we don't know. The percentage of error is given as 1%. So what is the formula for percentage of error? So percentage of error can be taken as measurement value minus true value by true value into 100. So that is given as 1. So measurement value is 100, true value we don't know, and true value into 100. Okay. So what is going to happen here? Now this is going to become as 1 by 100 is equal to 100 minus true value by true value. So this is the true value, this is 100 minus true value into 100. Okay, so what is the answer is going to become, this is the true value, so this is 100, 2 more zeros, minus 100 dB. So 101 into true value is equal to 10,000. Okay, so true value कितना होगा? So true value is equal to 10,000 divided by 101. So answer कितना आने की chance है इधर? Just answer this question. Yes, 10,000 divided by 101. So it is coming around 99 ohms. The true value is 99 ohms. Possibly true value will be always single. Okay. Okay. Chalo, let us go for the next question. Yeah, try to answer this question, make it fast. Yes, clear? Please answer this question. A voltmeter of internal resistance 10 kilo ohms is used to measure the voltage across a 10 kilo ohm resistor connected in series with another 10 kilo ohm resistor across a 10 volt supply. So this question is related to loading effect. So now if I am going to draw the circuit like this, so this is the circuit. So this is plus minus, these are 10 volts, and here I am taking a resistor. So this resistor is now a voltmeter of internal resistance 10 kilo ohms. This is a 10 kilo, sorry, used to measure the voltage across a 10 kilo ohm resistor. So there is another 10 kilo ohms resistor here. There is another 10 kilo ohms resistor here. Another 10 kilo ohms resistor here. Across a 10 volt supply. See, question is a voltmeter of internal resistance. So there is a voltmeter like this. So there is a voltmeter like this. There is a voltmeter like this. So this voltmeter is having some internal resistance. This voltmeter is having some internal resistance. This RM. The meter resistance is 10 kilo ohms. The meter resistance is 10 kilo ohms. So now those both are parallel. Then what is the answer of this voltage? So loading effect. So these two are in parallel. So the net resistance will be what? The circuit will become like this. So this will become as 10 volts. So this is 10K. And it will become as how much? These two are in parallel. It will become as 5K. So now what is the voltage across this load? If you check, that is 5 kilo ohms divided by 5 plus 10, 15 kilo ohms into supply voltage 10. So answer will be coming as 5 by 15. So 3.33 volts is the right answer. Yes or not? So 3.33 volts is the right answer. Yes, Prashant. 3.33 is coming or not? Prashant Yadav, good afternoon. Okay, done. Any other doubts? Yeah. Chalo. Next, let us go for the next question. Answer this question. A PMMC instrument has flux density 0.5 Weber per meter square, number of turns is 100, coil area is this, control spin constant is this. Find the deflection when a current of 10 milliamperes flows. So how to answer this question? So if you see, the deflection torque is given by the formula bina. Controlling torque is given by the formula Kc theta. Deflection torque is bina, controlling torque is Kc theta. So at steady state, The bina can be written as Kc theta. So question asked here is find the deflection when a current of 10 milliampere flows. So theta is equal to BINA divided by Kc. Okay, so this is the bina by Kc. So how to find out the deflection? So B is equal to 0.5 Weber per meter square. So theta I am taking here. So this is the theta. So this is 0.5 Weber per meter square. Next, I is the current. What is the current? We have to find it out, right? Current only we have to find it out. So he's asking deflection. So we have to find out the deflection. So let me write. Okay, current is given. Current is given. Sorry. Current is given. Current is equal to 10 milliamperes. So I can write it as 10 into 10 power minus 3. Next, number of turns is equal to 100. So the number of turns is equal to 100. Next, what is the number of area? Area is 2 into 10 power minus 4 meter square. So 2 into 10 power minus 4 meter square. Next, divided by Kc. Kc is the control spring constant. That is also 2 into 10 power minus 5. 2 into 10 power minus 5. So what can be the answer now? So this 2 gets cancelled. 10 power minus 4 minus 5. 10 power minus 1 gets cancelled. 10 power minus 2. 10 gets cancelled. So answer is coming as 5 radians. Right? Answer is coming as how much? 5 radians. Is it right? Theta is coming as how much? Good afternoon, Sujata. What is the answer? Please check it. His answer is 5 radians is correct or not? Please check it. Is 5 radians correct? Okay, done. So let us go for the next question. What is the answer for this question? A CRO has a bandwidth of 5 megahertz. What is the maximum frequency of a sinusoidal signal that can be displayed with less than 3 dB attenuation? Try to answer this question. Make it fast. See here, very good question. Actually, he has given attenuation. Attenuation is given as decibels. So attenuation formula 20 log base 10 V out by V in. Am I right or not? So that is the basic formula of attenuation. So the V out by V in is given as 3 decibels. 3 decibels means that is 20 log base 10 V out by V in. So how much it is going to become? So 3 decibels, we check it. How much is going to come? 10 to the power of 1.5. So it is going to become as 1 by root 2 or not? So V out by V in, how much it is going to come? So 3 by 20, so 0.15. So 10 to the power of answer is coming as, how much it is coming? Root 2 is coming or not? Attenuation is given as 3 decibel. 3 decibels is attenuation. Now we should take minus. Okay. So if you check now, so this will become as minus 3 by 20 minus 0.15. So log base 10 V out by V in. So the V out by V in, if you check now, it will become as 10 to the power of minus 0.15. 10 to the power of minus 0.15, how much is going to come? 10 power minus 0.15 is going to come as 0.707. That means definitely the V out will be 0.707 times of V in. 0.707 times of V in, my dear. So please remember this. So what is mentioned? CRO has a bandwidth of 5 megahertz. What is the maximum frequency of a sinusoidal signal that can be displayed with less than 3 dB attenuation? You understand my point? So when he has mentioned the maximum is 5 megahertz, he is asking the what is the maximum frequency of a sinusoidal signal will be, that will be bandwidth of 5 megahertz. So no need to much working on this. So question बेकर question है 5 megahertz is right answer. इसमें दम नहीं है question में. See, the maximum will be 5 megahertz, the minimum will be that. Hello, yes, 5 megahertz is the right answer. Maximum will be 5 megahertz. Not a big issue. Next. Answer this question. A signal is applied to the Y plates and a standard frequency of 1 kilohertz is applied to the X plates. The Lissajous pattern shows 3 horizontal tangencies and 2 vertical tangencies. Okay, so what I can write? Fi by Fx. Fi by Fx is equal to number of horizontal tangencies divided by number of vertical tangencies. So what are the number of horizontal tangencies? Number of horizontal tangents is 3, number of vertical tangents is 2. So Fi by Fx will be equal to 1.5. He has given a signal is applied to the Y plates and a standard frequency of 1 kilohertz is applied to the X plates. So Fy is equal to 1.5 times of Fx. Fx is 1 kilohertz, so that becomes as 1.5 into 1 kilohertz. So that becomes the answer as 1.5 kilohertz. So the right answer for this question here is what? 1.5 kilohertz. 1.5 kilohertz. Am I right? It's a very easy question. Miss मत करना question को. So let us go for the next question. This one. A 4.5 digital DVM has a full scale range of 20 volts. Find the resolution. So resolution can be how it can. See, 4.5 DVM means what? 4 full digits and 1 half digit. So these are the 4 full digits. So 1, 2, 3. So 4 full. 1, 2, 3, 4 half digit. So these are the full digits. So they are 0 to 9 and this is a half digit. So half digit means what? Half digit means 0 to 1. Half digit means 0 to 1. Okay. So now if you see the range, it can be 0, 1, 2, 3, 4. So 1, 2, 3, 4 and goes on like this. 0, 9, 9, 9, 9. Next it will be 1, 0, 0, 0, 0 goes up to 1, 9, 9, 9, 9. So the total counts are how many? The total counts. So total counts are 20,000. Total counts are 20,000 and the maximum voltage is what? Maximum voltage is 20 volts. So the resolution is given by V max by total counts. Okay, अभी कितना आएगा एक बार confirmation कर दीजिए. So this will V max is 20 and this is 20,000. So answer is 1 millivolt. So please make a note of these points. Any doubts? Let me know. Any doubts? Chalo, let us go for another question. See, now before going, what is the answer for this question? The deflection sensitivity of CRO is given by S is equal to Y by VD. It is directly proportional to dash. Accelerating voltage, distance between the deflecting plates, length of the deflection plates, electron charge to mass ratio only. See, in CRO, the deflection is different, deflection sensitivity is different. Deflection D, excuse me. In CRO, deflection D is given by what? In CRO, deflection D is given by what? That is the formula LLD ED divided by 2D EA. LLD ED by 2D EA. So deflection sensitivity is S, that is output by input, that is D by ED. So that will become LLD by 2D EA. LLD by 2D EA. So output by input, LLD by 2D EA. Got it? So now if you see, the sensitivity is proportional to accelerating voltage, distance between the deflection plates, length of the deflection plates, electron charge to mass ratio only. So if you see, D is proportional, sensitivity total overall is proportional to capital L or proportional to LD and inversely proportional to accelerating anode voltage and inversely proportional to distance between the plates. So accelerating voltage ki inversely proportional, so it's wrong. Length of the deflection plates, distance between the deflection plates, distance between plates small d, so this is also wrong. Electron charge to mass ratio, this is also wrong. So this is the right answer. Why? Because deflection is directly proportional to what? Length of the deflection plates. So the right answer is option C. Excellent. Excellent, Sujata, you are right. So quality question, na? So please remember this. If you remember this formula, and automatically you can remember these other formulas. Deflection, sensitivity, alag alag hai. Okay. Can you answer this question? A first order instrument as a time constant tau is given as 2 seconds. The time required for the instrument to reach 63.2, it's not a valid question. Answer these questions. I think as a control system question you kept. But anyway, you can have some idea of these controls, right? So you can post. Anybody can answer this? So first order instrument hai ye. So this is a first order instrument. So you are giving the x of t and we are going to get the y of t. Okay. So for the first order instrument, what is the response equation? Y of t is equal to final steady state value into 1 minus e power minus t by tau na? Yes. So we can get y of t is equal to final value into 1 minus e power minus t by tau. So he is telling that the y of t is equal to what? Tau he has given as how much? So what is asking? At t is equal to tau, if you check now, first order instrument has a time constant of 2 seconds, the time required to instrument to reach 63.2%. So the time is nothing but 2 seconds only. Na? At 2 seconds only it will reach to 63.2%. So if you take y of 2, yf, that is 1 minus e power minus 2 by 2. So how much you are going to get? You are going to get 63.2%. So the right answer is 2 seconds. The time constant 2 seconds, the answer is option B hai. Chalo, before going for the next question, let me revise some important things for you. Revision. See, first let me start from the measuring instruments. Let me start from the measuring instruments. In the measuring instruments, what I can give? What are the concepts to be revised? Listen carefully. Yes, Prashant Yadav, what are the concepts to remember in the measuring instruments? Suppose if I am taking the PMMC, in PMMC the concepts are what? The deflection torque formula you have to remember, bina, and the controlling torque formula you have to remember, Kc theta. So at steady state Td is equal to Tc. So bina is equal to Kc theta, so theta is equal to bina by Kc. And equal to Kc theta, and at steady state theta is equal to Kc theta is equal to this. So theta is equal to 1 by 2 I square by Kc into dl by d theta. Next comes dynamometer. If you see the dynamometer, the deflection torque is equal to I square dm by d theta, controlling torque is equal to Kc theta. So at steady state theta is proportional to I square by Kc dm by d theta. For there, समझ रहे आपको? Next, and if you see the range extension formulas for the PMMC, for PMMC what are the concepts we have to take? Range extension, so that is RSH is equal to Rm by m minus 1, and series resistance is equal to Rm into m minus 1. Okay. So based on this, let us take some questions on the measuring instruments. What type of questions are asked? Yeah. Try to answer the questions one by one. Answer this question, make it fast. Answer D hai? Okay. See, just before I told you, so this is the formula. So this is our meter resistance, this is our Im, this is our shunt resistance. So this I can go for I, this is the ISH. So RSH is equal to Rm by m minus 1. So the m I can take it as I by Im minus 1. So here if I check, now what is the meter resistance? A 1 milliampere meter movement with an internal resistance of 100 ohms. So this is 100 ohms is to be converted to a 0 to 100 milliamperes. So this is 100 milliamperes. This is 1 milliampere. What should be the shunt resistance? So Rm is equal to 100 divided by I is equal to 100 milliamperes, that is 100 into 10 power minus 3 divided by Im is equal to 1 milliampere, 1 into 10 power minus 3 minus 1. So 10 power minus 3 gets cancelled. So 100 by 99. 100 by 99. So 1.01 na? Right answer is 1.01. So don't miss this type of formula based questions, miss mat karna. Okay. Answer this question. Question is on moving iron ammeter. Chalo, what is the answer for this? The full scale deflecting torque of 20 amperes. So current is equal to 20 amperes, I is equal to 20 amperes. Moving iron ammeter is, torque is given, the torque is given as how much? 6 into 10 power minus 5 Newton meter. What is the rate of change of self-inductance with respect to deflection? So TL by dt is asking. So deflection torque is given. So TD I can take it as 1 by 2 I square dl by d theta. So this is 1 by 2. Current is 20 amperes, that is 20 into 20. And the dl by d theta is given as 6 into 10 power minus 5. So sorry. dl by d theta is asking, right? So dl by d theta we have to find. And TD is given as 6 into 10 power minus. So what is the answer now? So 2 to the 4 by 220. So please simplify and tell me what is the answer. Prakash, कितना आ रहा है? अरुण, 400 by 2. Okay, so this is 2, 10. Calculation 2 10 ja and yeah. Option D is the right answer. Okay. Answer this question. The current is given I of t. The current flowing in a 20 ohms resistor is given by equation 2 plus 4 sin 314t. The current is measured by hardware ammeter. What is the measured value? So that means IRMS. So IRMS is how much? Please find it out. Answer for this question. So IRMS. So that means how I can take. That means I can take it as square root of. See why? Because hardware instrument measures like this. So this I can take it as. So this I will take it as 2 square plus 4 by root 2 whole square. So that will be how much? 4 plus 16 by 2, that is square root of 4 plus 8. So root 12, that means square root of 4 into 3, that means 2 root 3. So 2 into 1.73. 2 3.464. Option B is the right answer. So let us go for another question. Answer this question. Yes, Sujata, answer this question. Match list 1 with list 2 and select the correct answer using the codes given below. ऑप्शंस लिस्ट 1 में पीएमएमसी दिया है, मूविंग आयरन दिया है, थर्मोकपल दिया है, इलेक्ट्रोस्टैटिक टाइप दिया है. लिस्ट 2 में इसका फॉर्मेशंस दिया है. ऑप्शन बी आ रहा है. ओके, सी हियर. PMMC is linear scale over the entire range. S. We'll go this. Moving iron is square law, right? Electrostatic type is a voltmeter, electrostatic voltmeter. Thermocouple is always having high frequency response. So what is answers? So A goes to 3, B goes to 1, C goes to 2, D goes to 4. So 3, 1, 2, 4. 3, 1. So option D is the right answer. Option D is the right answer, na? कैसा है option B? B goes to 1 na, square law. Why? Because moving iron will be having half I square na, Sujata. Yes, this will be half I square. Moving iron is having half I square dl by deta. So 3124 is the right answer. So let us go for another question. Answer this question, make it fast. A moving coil meter has a resistance of 3 ohms and gives a full scale deflection with 30 milliamperes. So this is 30 milliamperes, this is 3 ohms. What external resistance should be added in series so that it can measure a voltage up to 300 volts? So if you see this, so this is a series resistance. So this is a series resistance. So this is a voltmeter. So this is a meter resistance. Okay. So this is a moving coil meter has a resistance of 3 ohms and gives full scale deflection with 30 milliamperes. What external resistance should be added in series? So what should the series resistance should be added in series so that it can measure a voltage up to 300 volts. So this voltage will be 300 volts. So full scale voltage is 300 volts. And so this one is given current as 30 milliamperes. So now we can find out the Vm, right? So this voltage is Vm. So we know that RSC is equal to Rm into m minus 1. So m means we can write it as capital V by small vm minus 1. So now if you write everything, RSC is given as, what is the meter resistance Rm? Meter resistance Rm, that is 3 ohms. This is 3 ohms. Capital V is 300 volts. And the Vm is equal to 3 into 30. That means 3 into 30 is 30 into 3, 900. 900 into 10 power minus 3, 900.9. 3 into 30, 90 into 10 power minus 3 minus 1. So how much you are going to get? This is 30,000 divided by 9 minus 1. आंसर कितना आ रहा है यार? 30,000 divided by 9 minus 1 into 3. 997. So 997 आ रहा है. Right answer here is 997. Option B is right answer. Chalo, let us go for the next question. Answer this question. So A is former, B is coil, C is core, D is spring. So spring provides what? Spring provides the controlling torque. In PMMC, spring provides the controlling torque and the coil provides the deflecting torque. Okay, na? And core makes the magnetic field as radial, former makes the base for the soil. So A goes to 2, B goes to 1, C goes to 3, D goes to 4. So 2, 1, 3, 4 is the right answer. Option C. Okay. Is it okay for today? So in the evening session, 7 p.m. session, we are going to discuss some other questions. Okay. Some tough questions we are going to discuss, my dear. So please be attentive in the evening session also. 7 p.m. को एक सेशन है, so मिस मत करना वो सेशन को. आज डिस्कस कर, आज करें, देखेंगे, आज का शाम को देखेंगे.